Hello everyone, welcome to this session on deploying multiple machine learning models using AWS Lambda and Amazon EFS, which is our elastic file storage system that we have, the offering that we have for network file storage. So what we are going to do today is we are going to share you one of the solutions that you can think of or you can use to deploy your machine learning model for a more performant deployment or inference, as well as more cost effective in terms of the overall solution. So what we are going to do is we are not going to go over dry slides and go over different services one by one, but we will take a different approach where we will straight away start off with our demo, and we will try to understand those concepts and services and how they stitch together as we go through, right? And there are some prerequisite for this session to make best out of it is you should have a basic understanding of the serverless technology, not essentially AWS Lambda. If you know it, nothing like it, but just a basic understanding would be great. You may like to refer to getting started with serverless and other Lambda sessions on Reskill platform. And I'll cover the EFS part, although we have a session on Amazon EFS. You can check that out as well, where we deep dive into EFS storage system and how you can make use of that for your distributed application. So that's about it, and I'm going to share you the code as always, and you can play around with that, and feel free to reach out to me at later point in time if you have any questions or anything you want to build on top of this. I'll be more than happy to help you. So this is my contact. You can reach out to me over LinkedIn. I work as a principal developer advocate here at AWS, and I'm based out of Bangalore. So without wasting much of the time, let's get started. So this is the only slide that I have for this session. So this is just to give you a intuition of what we are going to build now. So first thing first, although we are talking about machine learning models here, but the focus is not on the machine learning side. Okay, so you don't have to understand or learn about machine learning to understand this demo or this solution. But the idea is you can pick any machine learning problem that you are working with, right? So it can be an image classification problem, it can be a natural language processing problem, whatever it is. But the idea is you can pick any ML problem or machine learning problem and use it using this architecture. Okay, so for this demo, we are going to pick one of the problem where we will be using a model which was trained for extracting text from an image. Okay, and it's an open source model. It's not trained on SageMaker. We are not going to do the training on SageMaker, but what we are going to do is we are going to take those model outputs or model artifacts, to be very precise, and those are nothing but weights. If you are into machine learning, you would know what weights are. Those files contains the weights and other parameters for that particular model, and we are going to deploy that using serverless or AWS Lambda. Okay, so this is how it's going to work out. So what we are going to build is we are going to have an API gateway, and the clients will send the images or the link of the image, because the problem that we are trying to solve is extracting text from an image. So obviously the user will send an image, right? So here the image the user will send is not the direct image, but they will send an HTTP URL, right? So it can be even an S3 bucket link, or it can be an image from the internet or anywhere, right? So basically the client will send an HTTP request using the API gateway, or the URL using this API gateway, and that API gateway will trigger a Lambda function, and that Lambda function will go and it will trigger that Lambda function, and that Lambda function will then read the model artifacts which are stored in this Amazon EFS storage. Right. So before we even start the invocation, we have to make sure that all the model artifacts are saved in Amazon EFS. Okay, that's the whole idea. right? And once the inference is done, the AWS Lambda will send the response back to the user. Okay, so this is a pretty simple architecture, but it has lots of components. And what we are going to do is, we will deploy all of this using SAM CLI or the SAM framework. So if you are new to SAM, SAM is one of the framework that we have for serverless application deployment, where you can build and deploy your serverless application seamlessly. So under the hood, it uses CloudFormation templates or CloudFormation service. And if you are new to CloudFormation, so CloudFormation is the service that we have at AWS, which is kind of a infrastructure as a code. So you can think of it as a if you want to automate something, any deployment or anything on AWS, you would probably use CloudFormation. So it is native to AWS, but it's just like how other third-party softwares or tools that we have for deployment of infrastructure on the cloud, like Terraform and so on and so forth, right? So that is what we are going to do. So with that, let me just share you the link for this demo. All the code and everything will be available in this GitHub link, and you can refer it to this after this session, right? So whenever you get time. Let's get started. So I will keep this image open so that in case we want to refer to this, we will come back and see this. All right, so we have already logged into our AWS account, and if you see, we have a service called Cloud9, right? Because we are going to build everything using SAM CLI, and I don't want to use SAM CLI from my laptop. And what I generally do is I create a Cloud9 instance, and I work on that Cloud9 instance. So the Cloud9 instance is basically a virtual machine which gives you an IDE kind of environment, which looks something like this, right? Where you can write your code, you can edit your code, and also you will get a command shell. But this is all running on an EC2 instance on the cloud, right? So, but you don't have to configure and manage all of this. It will be automatically provisioned for you, and everything will be set up for you by AWS under the hood if you use a Cloud9 instance. So I already have two Cloud9 instance. I have already opened this. So that's what I was showing you in the other tab. But if you are getting started and if you want to make use of Cloud9 or leverage this service, you can click on create environment, and you can give some name, and it's quite a simple wizard where it will ask you to select the type of EC2 instance that you would need for this Cloud9 instance. So it's a pretty straightforward thing. I'm not going to show you that, but I would highly recommend you that for any of your development work, try to use Cloud9 instance rather than using your own laptop or desktop. Okay, so now here is my Cloud9 instance, and I have logged into my home directory. And if you see in the left hand side, I have lots of folders because I've been using this for various other projects. But if you are doing it for the first time, you will probably see an empty list in the Explorer on your left hand side. Okay, so there are a few prerequisites for this to get started, but I'm not going to show you that, but I'm going to tell you what are those things. One is you should have AWS CLI and SAM installed, right? So if you need the URL of this, I can add that into this GitHub repo. So this README is not updated, so I'm going to update this README file, which will contain all the information. And all the code for this particular demo are there inside this model inference folder, and which we are going to see at later point in time. Okay, so the first thing, let's assume that we already have AWS CLI and SAM configured and installed. We can check the version as well. Let's do that. As we can see, we are running with 2.0.30 version. That's fine. And let's see the SAM version, and it's 1.19. I guess there is an updated version after this, but that doesn't matter. But I would always recommend you to use the latest one. Okay, so that's about it. So the first thing that we need to do is we need to create an ECR a repository. Okay, and why we need to create an ECR repository? Let's go back to this page, to this architecture. So what we are going to do is we are going to create a Lambda function using a Docker container. Okay, and we are going to build that container from scratch. So from scratch, in the sense, we will be using a container image to create this Lambda function, right? So when you create a Lambda function, you can create it in different ways. You can just write the code, you can share the code and mention the runtime. That is one way to create, and AWS will pick the right container for you. That is one way to do this. And another way to do is, you only, bring your own container, right? So when you do that, then you need to have that container image in AWS, right? And the place that where we store all the images on AWS is ECR, right? So if you just come to this console, and let me show you this new capability of creating a Lambda function using container images. So if you come to the Lambda console and click on create function, the normal way or the usual way that we used to create a Lambda function is by giving a function name, let's say foobar, and you define the runtime, let's say Node.js, and you just click on create function. So what happens at this point in time is, AWS will pick some container which has, which is the right container for Node.js. So it will pick up a container image from it internally from its repository, and it will, use that container image for creating our Lambda function. So that is how, we used to work earlier. But now what we can do is we can actually create a container. We can actually, give a container image of our own from our side. So let's say you want to compile and build a few of the images which you feel that you need more control on, and you need to customize things. So you can always make use of your own container. But when you use that, you need to make use of ECR service, because if you see here, it asks for a container image URI, right? So and that is why we need to have a repository beforehand. We are not going to use UI, so that's why I'm not going to go through this. But I just want to connect the dots. How what we are going to do through CLI, same is available in the UI as well. So let's go back to our CLI, and the first thing that we need to do is create a repository, because later on we are going to use this repository while we build our serverless application, right? So to create a repository, let's run this command: AWS ECR create repository. And the repository name. Let's say I give some name. You can give any name of your choice. Okay, so as you can see, the repository got created, and what we can do is, we can copy this link, because we are going to use this at later point in time. So let's copy this URL, and I'm going to save it in my notepad. Let me do that. Okay, so I just saved it, because we are going to need this URL at later point in time. So the next thing that we need to do is we need to create a serverless application, and the way that we can do using SAM is using this command SAM init. So what it does is basically it will instantiate an serverless application through a interactive wizard, and then it will create a folder for you. Inside that, we will get some boilerplate code which we can modify later on. So everything will be in a nice structure format, as SAM would expect. Okay, so First is we need to select the options now. So for this, we are going to go ahead with the quick start template. And since we are going to use a container of our choice, we are going to select the option 2, which is image. Otherwise, generally you will use, you might have used the first option, which is zip, right? So where you just share the code, or you just write the code, and image are picked up automatically based on the runtime that you select. So the next thing is we need to pick the runtime. For us, we are going to use Python 3.8. So let's select 4. And here we need to give some project name. So let's give our project a name. So let's say my ML demo for reskill. You can give any name of your choice, doesn't matter. And then you can pick up one of the template. So every runtime will have a different quick start template. If you have used let's say Node.js, you would have got a different set of templates. So don't get surprised if you see a different option for different runtime. So for our case, since we are going to use Python, and we are going to use PyTorch, because we are going to use a few of the libraries that are used by PyTorch in this demo. So let's select 2. That's all. So once this is done, what you will see is if you do an LL, you'll find a folder called my ML demo reskill, because this is the project name that we have given, right? So let's get inside that. And if you see in the left hand side, we already have that folder created, right? And it already have few of the subfolders like app. Inside that, we are going to have the actual Lambda function or the application code in the in this file app.py. And also we need to define the Docker file, because we have used the image format, image type. If you remember a while back, if I scroll up, this is the place where we define that we need this project to be in the image type format, right? So that's why we got this file, Docker file here. Okay, and the other thing is we can also see the YAML template.yaml file, right, which is our SAM template file. Okay, and this is the file which we need to modify. So the first thing that we will modify is maybe the Docker file. So let's open this Docker file, and what we can do is we can delete all the boiler code that is there, and I'm going to paste the code that I have already saved in the GitHub repository. I'm just copying it from a different terminal. So here what we are doing is it's pretty straightforward. We are taking a base image of Python 3.8. We are copying the requirement.txt file to the present working directory, and this is the requirement.txt file which we are going to update in a bit. And then we are going to install all the packages that are needed for our application, and we are going to create a folder called mnt/ml. And the reason that we are going to do this is later on, as we have just seen, we need to mount the EFS file system into this container, right? So this is the mount point that we are going to use. So that's why we are just creating a folder, while the container gets spin up, right? So that's why we are defining it in the container image itself. And then we are copying the Lambda function, which is written in this app.py file, right? This is the file which we need to update. And then we are just running this app.lambda handler, which is the actual Lambda handler or the Lambda function that we are going to have, right? So we are going to edit this file, and we are also going to edit this requirement.txt file, right? So let's save this file and close it. And the next thing that we need to update is maybe the requirement.txt file. So since we are going to use few of the libraries for this inference, and for that, I just kept few of the libraries here. And one of the major library that we are going to use is EasyOCR, which is an open source project. Let me just show you. So this is the URL uh, of the Easy OCR, and this is the package that we are going to use. And it clearly says that Easy OCR is a Python package for extracting text from image, right? So, and it has lots of language support, as we can see, but we don't have to focus on the actual ML model here, because this is just for this demo. But you can pick up any machine learning model which you use for your for your business problem. And the idea is how you can make use of EFS and AWS Lambda to deploy your serverless application for those machine learning models, right? So that's the whole intent of this demo. All right, so we have saved this requirement.txt file. Let me close this. So we are done with the Docker file. We are done with the requirement.txt file. The next thing is we need to update this app.py file, right? So let's open this file. And what we are going to do is we are going to paste some code which I have written, which I've pushed in the GitHub repo. And I'm going to delete all of this, and I can just paste it here. So here, we are not doing much of a fancy thing, but I'll just walk you through quickly about this code. So the first thing is we are importing Easy OCR because that is the model we are going to use. And then we are reading few of the environmental variables called model dir or network dir. And these are nothing but the EFS shares, right? Because the EFS will be mounted on MNT/ML, right? So we need to make sure that all the model artifacts that we pick from this package, right, all are saved inside this models folder, right? So we need to make sure that we do that. And we also have a network folder, right? And this is how it will come to know about this environmental variable. We are going to define this in our SAM template, right, which I'm going to show you next after this after this walkthrough of this code. And then we have this Lambda function, and this Lambda function will be triggered via an API gateway. So what we will do is we will just read the body of the request, and in the body of the request we will be sharing, the user will be sharing a link and the language that the text is inside that image, right? So the link will contain the image, and the language is the language that user know that the text would be for on that particular image, right? So let's say you have an image with some English text, so you will send the link of the whole image, and in the language section you will mention English, right? So that's about it. And then what we are doing is, it might so happen that you have different language in the same image, right? So you might have English and Hindi mix in a particular image, so you can specify those as well. And this is what we are parsing and saving it into a list, a language list variable. And then what we are doing is we are loading the model, right? So we are using a little bit of caching within this Lambda function, and that's why we have this model cache dictionary, so that you don't have to, if you do an inference for the same language with different images, it doesn't have to load that model artifacts over and again, right? So just these few lines of code from line number 20 to 22 is just for performance improvement. And once we read that, then we will be sending the data, and the data would be in this link hash, right? So because the user will be sending some URL, and that URL we are going to parse to send to this read text method. And this is the one single line of code which can do that prediction, right? So we are going to pass that image URL, and this reader object has a method called read text, which will read the text from that image, right? And then what we are going to do is we are just going to format that response that we get from the result. If you are curious, while you are deploying this, I would recommend that you first print this out, right? So that you can you would know that why I've used the first index of every element in this results list, right? So I generally do that, but always check what the response of a particular method is before you do any formatting, right? And towards the end, we are going to just dump the response on the logs. Okay, and it will be returned to the API gateway as well. So if any user sends the URL and the language, it will get as a response as the prediction. Okay, so let's save this file as well. So we are done with the Lambda function. We are done with the Docker container file or the Docker file. And we are done with this requirements.txt file, right? So everything is done inside this app folder. Now, the last thing, which is the most important thing, which is left is the SAM template. And to edit that, we need to open this template.yaml file. And this is the SAM template file. And what we're going to do is we're going to delete all of this, and we will paste our code. Again, this is all mentioned in our GitHub repo. Please refer to that. You might have to change a little bit here and there, and which we are going to show you as we go along. So what I'm going to do is I'll quickly walk you through the SAM template and share what SAM template is doing. So as I mentioned, SAM internally uses CloudFormation, right? And this is meant for specifically for serverless. Although you can do a lot of things outside serverless, but this is majorly built for ease of deploying a serverless application on AWS. So the first two lines of code is basically we need to mention which tells AWS that, hey, this is a serverless template or SAM template. You need to convert it into a CloudFormation template, right? So that is the whole intent of the first two line of code. Third line is basically a description. You can put any text depending on the project that you are building. So for this case, we are deploying a machine learning model using AWS Lambda and Amazon EFS. So you can put whatever text you want. The next thing is the global section, and global section is the section where you can put something which is common across multiple resources that you are going to create in this template. So we are mentioning that we want to have these parameters as a global parameter. So let's say you create 5-6 Lambda functions using the same template. And if you want to set the timeout of all those Lambda functions as 300 seconds, you don't have to write that in the property of all those Lambda functions 5 times. Okay, so you can set it as a global variable or as a global parameter, and it will be cascaded to all the service, all the functions that you define, inside the SAM template. Although in this case, we just have one Lambda function, so it doesn't matter where you put it under the globals or inside the Lambda definition itself. But this is a good practice to keep it in the global section so that you don't have to go down and make changes in each and every entity. And then we are just defining some environmental variables. If you remember the apt.py file in the first two lines, we were reading this model dir and network dir, and this is coming from here because we are defining the model dir and network dir as this path, right? So if you want to change this path, feel free to change that. But you need to be mindful about the fact that what path you are defining for the Lambda function to mount the EFS, so that you can upload the models in the same share, right? Otherwise, Lambda function, when it will get triggered, it will complain and it will error out saying that, hey, I can't see the model files here, because you might have uploaded the model artifacts in some other location inside the EFS file system. Okay, so that's about it. And then if you scroll down, we have parameters, and this is very important as far as EFS is concerned. So to create an EFS file system, you need to define which VPC and which security group and security ID, which subnet that EFS file system should be created on. So that's why we have just kept these two parameters, and you will be asked for these two parameters or these two entities while you deploy this SAM template, and we are going to see that very soon. But I have kept the default value for my environment, but you need to change these two values for your environment, right? So if you want to know about which subnet you should use and which security group you should use, you can refer to the GitHub link which I have I've shared. Okay, so I'm going to put that in the README file. So I hope by the time you will watch this, that README file will be updated. All right. So the next thing is the most important thing, and that is the resource. So this is the place where you will define what are the resources or services that you want to use for your application. Or in other words, this is the place where you tell SAM that what are the resources that it should create on your behalf. So the first is we need to create a EFS file system. So that's how we say that you can give any name. Here we have given EFS file system, but you can give whatever name you want, and then you have to define the type of the resource. So the type of the resource is AWS EFS file system, right? So you can check the documentation of CloudFormation and SAM to figure it out. What should be the right resource name for your for a particular resource. And then we need to define mount target. So here we are defining a name. Again, it can be any arbitrary name. For this case, we are using mount target. But important thing is you need to mention the type correct, right? So you need to check the documentation to know what is the right type. So to creating a file system, EFS file system, you need to define a mount target. So this is the type, AWS EFS mount target, and we need to give some details. And this is what we were discussing a while back of security groups ID and subnet ID. So these two things are needed to create a mount target. So here we are just referring to all the variables, both the variables which we have defined earlier, right? So that's why it is taking the reference using this ref function, right? And also this mount target would be for this file system, and since this file system will also be created by SAM, and we don't know the name and the file system ID, and that's why we are just referring to this file system object which we are getting, which SAM will create. Right, so it's very dynamic, and there is no hard coding here, as you can see. So everything will be referred automatically. Now the other thing that we need to do is we need to create an access point. Now access point is not a mandatory thing from EFS standpoint to create, but for a Lambda function it is important, and it is a mandatory thing to access EFS from a Lambda function. And the reason being is if you are from systems background, or if you have ever worked on any network shared storage, or if you have ever used any network shared storage, you would know that when you try to access any network storage across the network, you need to have some credentials, right? So you need, as a user, you need to have the user ID or group ID and then the set of authentication happens at the network file storage side, and then you get the access. But in Lambda, since we don't have any instance, we don't have any EC2 instance, or we don't know, what magic happens under the hood, we just send our code, right? So for a Lambda function to access and EFS storage is ambiguous, right? So EFS gets an access request from a Lambda function, it would be ambiguous, right? Because there won't be any UID or group, user ID or group ID associated with that Lambda function, right? And this is where access point helps us, right? So access point can do that task for us, right? So it will help us to identify that, hey, this is the Lambda function which is trying to access, and we can define the user group ID in the access point. So if you want to know the details about access point and a Lambda function, I would highly recommend to go over Anand's session. I think he has recorded a couple of months back on EFS, I think modernizing application using persistent storage or using EFS. Just check it out. I think you will get that in the Reskill platform. So you will get more details about the access point. But for now, just remember that access point is needed to access any EFS file system from within a Lambda function. Okay. So once this is done, finally, we need to define the Lambda function, and this is the Lambda function that we have. And again, the type is serverless functions, and since it depends on the mount point, what that means is we are telling a SAM that, hey, this particular application or this particular function depends on this mount point, right? So make sure that while you create those resources, you wait for these mount target to get created before you start creating this Lambda function. Okay, so it's just like a reinforcing SAM that, hey, now you are going to create a serverless, you're going to create a Lambda function, but this Lambda function depends on this mount target. So SAM will automatically understand, or CloudFormation will automatically understand that I need to wait for this mount target to be up and running before we get started with the Lambda function creation in this section. Okay, so that's about that. That's why we have this depends on flag. And then we have to give some property about this Lambda function. This is an image type, as we all know, because this is how we started this. And then we need to give some policy, because this Lambda function need to read data from the EFS file system. So we are just giving some permission. We are also attaching the EFS storage, and that's what this file system configuration flag is about, where it just reads the access point ARN, and this access point is nothing but what we have created here, right? So that's what I was mentioning a while back, that for Lambda function we need to have an access point, right? So that's what it is referring here. And again, we are mounting it under this mnt/ml path. And this is important because if you remember in the Docker file, we have created this directory. And if you change this directory, you have to come back to this YAML template and make sure that you give the exact same mount point, right? So this is the directory where your EFS file system will be mounted. And then we are giving this VPC configuration again, the security group ID and subnet ID, because now this Lambda function will be deployed inside a VPC. Unlike a normal Lambda function, which doesn't come in your VPC, right? So if you go back to your Lambda function, if you have ever created any Lambda function, like I guess I should have some Lambda function created, let's say foo, this one. And if you come to configuration and come to VPC, you will see that there is no VPC configuration. So that's what the default. We create a Lambda function in our Lambda service VPC, which is not your VPC in your account, right? So this is important. So that's why we need to add this VPC configuration. And the reason that we need to add this is because we are accessing the file system, right? So unless or until we attach the Lambda function within a VPC, you cannot access a file system. Okay, and then finally, this is the event, or nothing but this is the trigger. We are explicitly mentioning that this Lambda function should be triggered by an API gateway. You don't have to create an API gateway separately. The moment you give events here and then you define the type of event, it will automatically figure it out that, hey, this user is asking me to create a API gateway. So let me create that. So this is what the type API does. Okay, and then you can define the path. So what should be the path which it should do the it should deploy that API gateway to. So this is what the path is, and we are going to use the URL soon after deployment, and we'll see that what this OCR is. And then we can define the method type. So method can be get, put, post, whatever it is. But for us, it's a post method because we are going to send the URL as an inference, right? So that's why the method is post. And the last thing is the metadata. So if you see, this is still in this indentation, right, inside this function definition, we know that this is going to be a Lambda function creation using a Docker file. So that's why we are mentioning this Docker file, and where is the Docker file exist, and what is the tag, right? So this is 3.8. Right, so that's about it. What we are saying here is where I can find this Docker file. So it's Docker file is inside this app folder, right? So if you see, this is the app folder. Inside that we have this Docker file. So we are done with all of these definition and creating the SAM template. The last thing is output. I don't want to go over this. This is just an you can delete it completely, but this is just to print out few of the resources that it will create. So like the API gateway, the Lambda function, and the IAM role, and so on and so forth, right? So this is just for your readability. So let's save this, and let us close this. So let me also close this Docker file, and this is also updated. Let me close this. So now the next thing that we need to do, we need to first make sure that we are inside that same project folder, which we are. And the next thing we have to do is SAM build. So let's do that. Okay, so it has completed the build, and the next thing that we need to do is we need to deploy it. So when you do the deployment for the first time, you need to use the hyphen guided option, or -G, so that you get an interactive wizard in front of you, and you can update and answer the questions that it will ask. And later on, once you have deployed this application, from next time onwards, you don't have to give that option. Okay, so for now you can either give hyphen guided or -G. So let us give some application name. So let's give the same name as our project, my ML demo reskill, and let it be in the US East 1. I know the security group ID is correct. So in case you have not updated the YAML file, but you can. So in case you have forgotten to update this YAML file, which with this default value. If you come here, if you remember that we have kept some default values, right? So even if you have not updated it here, while in this wizard, you can always update that. So let me go ahead with the default, because I know these are the settings for my environment. Now here it is asking for the ECR repository, because it is going to create a container, and it is going to push that container image into the repository. So I have already copied that repository name, and let me just paste it here, and let's go ahead with no, I don't want to confirm. That's okay. Let's allow the IAM role creation, and here it is saying the inference function may not have authorization defined, and that is true, but for this demo it's okay. We are not using any authentication, which generally in the production you would use, but for now it's okay. And we need to we want to save this all this argument in a configuration file. And the reason that you should say yes is because next time onwards, if you want to avoid this -G option, then it will read that from this configuration file called samconfig.toml, right? So you don't have to redo this over and again for any new modification of your application. So let's wait for some time, and once this is done, then we will go ahead and do the next step, which would be uploading the model artifacts into our EFS file system. All right, as you can see, the SAM deployment is already over, and if you see here, this is the output section where it tells us all the resources that it has created. And if you scroll up, you will see, all the progress of all the resources while it was creating one by one, right? So yeah, it's quite verbose, and you get a feel of what it is doing under the hood. So that's the beauty of SAM. You don't have to do everything manually. Everything is managed by SAM. Just a few lines of code, and it will do everything for you. Okay, so now that we are done with our Lambda function, we can go ahead and do the inference, but it won't work because at this point the file system or the EFS file system doesn't have any model artifacts, right? And we need to put or dump all the model artifacts in that share, right? So to do that, what we can do is we can go to this Lambda function, which it created. So if you see, it got created just 2 minutes back. So let's get inside this. And if you come to this configuration, and if you scroll down to file system, you would know that there is a file system got attached, and it got created by the same SAM template, and also it got attached through a access point. Now, if you click on this access point, it will open up in a different tab. And here, what we are going to do is we are going to attach this access point. Okay, so what we can do is click on this attach button, and it will give you a command which you can use to mount it in your system, right? So I have already created an EC2 instance within the same subnet where this Lambda where this EFS file system is created on, so that we don't see any access problem, right? So what I've done is I have already logged into that SSH to that EC2 instance, and if you see, I have an EFS folder created, and this is where I'm going to mount. So if you see here, it is empty, and if you see, there is no mount point, right? So now let's go ahead and run this command. So what it is doing is it is mounting this file system in this mount point called EFS using this. We are using this tab as EFS minus type as EFS, and it is working because this is not a regular NFS client. The reason that it is working with this minus T EFS option is because I have installed the EFS utility tool, okay, which is a wrapper around the client that we have. And what this does is it is always recommended to use this wrapper utility because it helps you to securely send data from this machine to your network file storage, right? So there are a lot of TLS and other things are involved. If you want to get into more details about what are the different ways that you can mount EFS file system in your system, you can refer to the EFS developer guide. Okay, but now that it is mounted, if you see. Here it is mounted, so it is not giving you the exact share name because we have used the minus T EFS option, and but you can see that it has been mounted in this folder, right? So now what we can do is we can get inside this EFS folder, and here we can dump the models. So I guess I have my models save in an S3 bucket. So what we are going to do is we are going to just copy all those models in this share. So let's wait for some time. So if you see here, now we have this zip file, but we need to unzip that. And let's wait for this to complete. So the value add of using an EFS file system with your Lambda for machine learning inference is that going forward, if you want to update your machine learning model or any new training that you have done with a new set of data, you don't have to redeploy your serverless application. All you have to do is you just have to come here or any EC2 instance or any machine, and you can just dump the latest data, right? Your serverless application will be always up and running. In fact, you can do even one level, advance where you can create a Lambda function and that Lambda function will be triggered whenever a new model file is uploaded in an S3 bucket, right? So that you don't have to mount this file system and copy this manually, right? So the moment you have a new artifacts model artifact, you just upload it into a particular S3 bucket, and that will trigger a task which will copy that file and dump it into this Lambda function, into this EFS storage, right? So you can do that. So anyway, so we are done with this. So now we have this models folder, and what we can do is we can just remove this zip file because that is not needed, and we can also delete this folder, which is just a auxiliary folder. So now if you see LL models, you'll see all the model artifacts that we have saved here. So again, depending on what type of machine learning model you're using, you can dump all the artifacts, whatever you have, into this folder, right? So once that is done, if you now come to this app.py, I just want to remind you that we are adhering to the right folder path. So we know that the model directory is under MNT ML models, and we have created this folder called models, and inside that we have everything, right? And this MNT MNT/ML is the folder where this EFS file system is mounted on the Lambda function, right? So if you again open this template.yaml and come down to local mount point, it is MNT/ML, right? So far so good. So at this point, I guess we are good to do the inference. Everything is everything is set up. So now what we can do is we need to know the endpoint, right? So if you just refer to this image, we have deployed this API gateway, Lambda function, and EFS storage. All of that is done. But now to do this inference from this client, we need to know this API endpoint, right? And this API endpoint is created by the SAM template itself. And one way to know what is that endpoint is to check this output, right? So in this output, you will find this API gateway. Right here, this is one place that you can just copy this link, or you can go to this UI and click on your function, which is this function. And if you click on API gateway and expand it, and you will find the exact same URL here. Okay, so now what we are going to do is we are going to use Postman, and I'm going to bring Postman here, and let me first replace this URL. Okay, and in this URL, in this in the body of this in this request, I'm just sending a link. And if you see this link, let me just open this in a different tab. This is the image, and if you see that it has English and I guess Chinese, I guess, or I'm sorry, I don't know which language is this, but we have two languages here, right? So let's go to Postman, and we can define the language as CHSIM, because this is what I read from their documentation, and English as EN, right? So now let's try to send the API call, and let's see what we get. So since we are doing this inference for the first time, so there might be a probability that first time it may time out, because that is the first time it is going to be a warm start, because it is going to create the container for you, and it will then will do the inference. So it might so happen that first time you may see a timeout, although there is a way that you can avoid that by using concurrency. But this is just a warning. But it worked fine. So if you see here, we got the prediction, and if you do it next time, it will be even faster, right? So every time you do, see, it's roughly around 2 seconds, and if you do it again, it's again roughly around 2 seconds. So you get the idea, right? So now what we are essentially doing is we are doing the prediction all in a serverless fashion. So our model is not deployed in an endpoint. It's just saved in an EFS storage, right? So all that is happening is the API gateway is sending this link, sending this URL to the Lambda function, and Lambda function is doing the inference from the EFS storage, right? So you don't have to pay for, let's say, if you have used this. If you have not used EFS storage, but you have used some endpoint which was hosted in some EC2 machine or in some container, then every time you send an API call, you will be charged. And not only that, that deployment will also will add your bill, because that system will be always up and running, right? So all of that, you don't have to pay now, because you just have to pay for the storage that you use for the EFS, but it would be much faster because it is a local the container which is used by the Lambda function will be having a local file system access, right? So it's not an HTTP request going outside the Lambda function, right? So I would strongly recommend you to try this out and see the whole thing, that how we can do machine learning inference using EFS, and you can build on top of this with different use cases. Okay, so that's about it. If you have any questions or any doubts about this, feel free to reach out to me. This is again the repository link, and I hope that you could comprehend few of the things that we wanted to touch base on as far as this solution is concerned. But there are few things which I skipped, but like configuring the subnet and connecting it with a NAT gateway and all of that. But I am going to put that into the README file, and that is little tricky. In fact, I will share you one more video, small video, which will showcase how a Lambda function within a VPC can get an internet access, because that is one place you might get stuck, because that is not something that you would generally do when you work with Lambda, right? So, and here we need to do that because the Lambda function is accessing the EFS storage. Okay, but do try it out, and if you have any questions or queries, feel free to reach out to me. Okay, so thank you so much for all of your time, and all the best for the quiz. I'll see you again soon in some other talk. Bye.